Let's get right into it. We're talking about one of the sneakiest, most dangerous failures you can have in production, the kind where everything looks perfectly healthy right before it all just implodes. So picture this. You're looking at your production dashboard. It's a beautiful sea of green. Your uptime is 99.99%. All your services are happily reporting back as operational. Every single health check is coming back with a perfect 200 OK. As far as you're concerned, the system is absolutely bulletproof. And then, bam, this ticket hits your inbox, an urgent one. A user's video is frozen solid. They can hear everything just fine, but they're invisible. They're frustrated, their meeting is ruined. And your beautiful green dashboard, it offers you zero clues. Nothing. This is the disconnect. Green dashboards, but very, very red users. And that right there, that's the real kicker. Your WebRTC app is actively failing where it matters most, for the user, but your monitoring tools are completely oblivious, just smiling back at you. That HTTP 200 OK, it's not nearly enough. And digging into exactly these kinds of tough, real-world problems, well, that's what we're all about here at Lalit Official. We give you production-grade engineering insights, no fluff. So here's the deal. We're on a mission to bring together our first 50 subscribers by February 28th, 2026. If we hit that goal, we're going to do a live deep dive session together. If you're a serious builder, you are definitely in the right place. All right, let's peel back the layers on this. The dashboard is lying to you, and we need to uncover this massive gap between what your servers are reporting and what your users are actually feeling. This slide says it all. It's like we're looking at two different universes existing at the same time. On the left, you've got the control plane. That's what your dashboard sees. Everything's great. HTTP check is 200 OK, API is reachable, server CPU is just chillin'. But on the right, you have the media plane. This is your user's reality. And it's a nightmare. The media encoder is stalled, there's a packet retransmission storm brewing, and their video is completely frozen. See the difference? You're measuring server availability, not user experience. You know, there's a name for this disconnect. It's called the observability gap. It's the total failure of our standard monitoring tools to see what's actually happening deep inside the WebRTC media engine, because that's where the real problems live. Packet loss, jitter, decode failures, and this shows a critical principle. The only real source of truth for media quality isn't your server, it's the client itself. So how do we fix this? How do we close that gap? We have to build our own telemetry. And it all starts with phase one, instrumenting the backend. We have to get eyes on the control plane first before we can even dream of understanding the media plane. And look, this isn't just theory. Here's a real code snippet using Python and a Prometheus client. What we're doing is creating a custom metric, a histogram, to track the latency of our signaling requests. We're setting up these buckets to see how many requests are super fast, kind of slow, or really, really bad. This is how you start to expose the real internal state of your signaling layer. And this brings us to an ironclad rule. If you can't measure the latency of your signaling, that initial handshake for a call, then you have absolutely no chance of reliably debugging why a session failed to connect in the first place. You have to start here. It's non-negotiable. Okay, so once we've got a handle on that control plane, we move on to phase two, monitoring the SFU, the Selective Forwarding Unit. This is where we can start spotting the enemy movements on the media plane itself, the early warning signs of trouble. Now, for anyone not deep in the weeds here, what's an SFU? Just think of it as the traffic cop for your group video calls. It gets all the media packets from every person and then forwards them to everyone else. And because it sits right in the middle of all that chaos, it's the perfect place to watch how the whole system is holding up under stress. And one of the most critical events you need to watch for at the SFU is something called a NACK storm. NACK stands for negative acknowledgement. It's basically a client yelling, "Hey, I missed a packet, send it again." Now, a few of those here and there, that's normal. But when tons of clients start yelling for lost packets all at once, you get a storm. It floods the network, and it's a giant flashing red light that a video freeze is coming. The whole game here is to shift from reacting to lagging errors like that angry user ticket to spotting leading indicators. NACK storms tell you about network trouble before the video freezes. High CPU saturation on the SFU tells you it's getting overloaded. And correlating bitrate with CPU usage, that can show you the exact moment your server's processing power becomes the bottleneck, not the user's Wi-Fi. Now, having all these metrics is great, but data without context is just noise. The real magic happens when you start connecting these dots. That's how you turn all this raw data into a proactive signal that can actually predict failures before they happen. This chart shows that magic in action. Look at this first bar. The SFU CPU usage is screaming at 95%. Now, at the exact same moment, look at the second bar. The NACK count has absolutely exploded to over 8,000 per second. And the result? Track this third bar down. The user-perceived quality has plummeted. Any one of these is just a number. All three together, that's a story. That's a failure about to happen. And this brings us to a critical rule for your alerting. Alert on trends, not static thresholds. A sudden, sharp spike in NACKs is a far more powerful signal than a bitrate that's just consistently high. It's the change, the trend, that predicts the problem. Okay, time for the field report. Let's lock in the key takeaways. 1. Uptime does not equal user experience. 2. An HTTP 200 OK does not mean you have healthy media. 3. Those NACK spikes are your single earliest warning sign of trouble. And finally, 4. Instrument your backend for this stuff before you even think about scaling.
This is what we're about at Lalit's Official. Real production-grade engineering. We want to take you from reactive firefighting to proactive, predictable system design.
So, here's your mission. If this was valuable, share this explainer with another serious developer who needs to see it. Hit the like button to support the channel, and definitely subscribe to Lalit Official so we can keep building this knowledge base together. We're aiming for our first 50 subscribers by February 28, 2026, and we want you to be one of them. Thanks for watching.